Hi, the question for today is converting a binary tree to a doubly linked list. So what you are given is that a binary tree uh, in this format, and what is expected is that you will be converting this binary tree to a doubly linked list. So the doubly linked list should be such that if you traverse in the forward direction, then it should give you the in-order traversal of this tree. So in order traversal means something like this: left, then root, then right. So if you write the in order traversal for this, it will be like first you go to the leftmost node, it will give you 25. Then next, since you have visited the left entirely, then you will be visiting the root, so 12. And then you'll be visiting the right, so 30. So now since you have visited the entire left part, now next will be your root, so 10. And you can also see here the same order is being followed: 25, 12, 30, 10. Now since you have visited the left, the root, next is to visit the right. So you come to this 15th. Then you have visited yeah, so next you should visit 36, since that is the leftmost node. So you visit 36, then you visit the root, which is 15. So in this way, you have to form a doubly linked list in this way. So what you can do in this question is that when you are given the tree as input, you can try to traverse the tree in order way. And let's suppose you are at this node, let's say 12. So uh, at 12, you will be interested in only two things. One is what was previous to that. So what you can do is I can maintain a previous pointer. So this 12 I can link to the previously visited node, which is 25. And the previous node, which is 25, I can link it back to the current node. So in that way, I'll be able to form this doubly linked list. So that's the idea to solve this question. So let's code it up. It can it will be easy to understand then. So as I said, we'll be just doing an in-order traversal of this tree first of all. So I'll write the code for recursive in-order traversal. So and here you visit the current node, right? That's the way you write in-order traversal of a tree. So what we'll be doing over here is that, as I told, when you're at a current node, then you will be linking this current's left pointer to the previous, and this previous node's next pointer, I mean the right pointer to the current. So first of all, you'll need to store a value of a previous node in this way. Now roots left would be equal to the previous pointer, and now you have to go to the previous one. So I can just check whether if the previous is not null, like if I'm at this position 25, like the head of the node, at that time there is no point going to the previous node and uh, linking its right to the current one. So only if previous is not null, only then what I'll be doing is previous is right. Previous will be your 25. So previous is right. That means 25's right must be equal to the current root. So this is it. And after that, you just update your previous to point to your root. So in this way, your tree will be built. Now the thing is that after you have built the tree, you need to return the starting point of the head. So, in some way you have to find this head and return it from this B to DLL function, right? So what I can do for that is like I can find the leftmost node that will become our head of the linked list. So so what this will be doing is that you will keep on going to the left until left is not null, and the point where starts left is null. You will be breaking out this loop. So at the end, start will be containing the leftmost node, and that will also be your head node, right? So what I'll be doing is that I'll be returning this start node. That will be my head, but before that I have to call the in order, uh, which will set this entire thing up of converting this to a doubly linked list. So let's test it out. Okay. Okay, the function's name are uh, yeah, so this works correctly. Yeah, so that's it for this video.